In 2010, the home stadium for the Minnesota Vikings, the Metrodome, collapsed because of the snow load. The Vikings had to play their home game at TCF Bank Stadium, where the University of Minnesota football team plays. The Vikings and HKS architects came together to design a new stadium for the Vikings. The design finally came out in 2014. The project was projected to be completed in about 2.5 years, but was actually finished 6 weeks ahead of schedule. The building doesn't only host Viking games, but also hosts concerts, soccer games, and other big sporting events. The stadium hosted Super Bowl 52 on February 4th, 2018. HKS architects designed the U.S. Bank Stadium. Some of the main architects that worked on the building were John Hutchins, Mark Williams, Heath May, Brian Truby, Kevin Taylor, and Scott Hunter. The project was constructed by Mortensen Construction.
The structural engineers for the U.S. Bank Stadium was Thornton Tomasetti, and the CEO of this company is Thomas Z. Scargello, who is a professional engineer. This company has 1,500 plus employees, headquartered in New York City, and was founded in 1956. They have 50 offices serving clients worldwide, and their main projects are skyscrapers, buildings, and structures. The mechanical and electrical and tech engineers for the U.S. Bank Stadium was Me Engineering, who the CEO is Mike Hart. This company was founded in 1981, and their mission statement and who they are, we combine exceptional talent and creativity with a real understanding of what people need from their environment. Our teams are made up of hardworking, uniquely experienced engineers who have completed command over the sophisticated technology essential for modern design.
The doors are one of the most spectacular parts of the building. In an article by CBS Minnesota, An Engineering Feat, The Doors at U.S. Bank Stadium by David McCoy describes how amazing these doors truly are. Steve Berg wrote a book about U.S. Bank Stadium from a fan's perspective. Steve says, quote, "Passing through a door like this is nothing else you've ever experienced. Doors are about transition. You go from a bright sunny day like today to a dark interior, but that's not what these doors are like. You don't know whether you're inside or outside. It's the absolute absence of contrast that confuses you." They are known as the 5 largest glass pivoting doors in the world. They stand 55 feet wide and range from 75 to 90 feet tall. Each door is roughly 30,000 square feet of glass and weighs over 40,000 tons. Steve Berg goes on to say, quote, "They are looking for something that was animated, something that would move, and these doors, because they pivot like this, they move, and they're actually more dramatic than a roof." The roof is made out of material called ETFE, which is a plastic-like material that has been used for over 30 years. It is light and stronger than a traditional roof. In the article, "The Roof That Isn't There" by Tim Newcomb, who works for Popular Mechanics, talks about how the roof was built. He says, quote, "Each of the ETFE panels in the Vikings' roof is made of 3 layers of ETFE foil, welded into panels with edges captured into aluminum frames, which are themselves connected to steel brackets of the roof structure. The outer layer of ETFE foil is printed with a silver ink to create a frit that helps reduce the heat of the sun on the roof's surface and deflect the sun, while the inner layer of air helps maintain the desired temperature, altogether controlling the thermal needs of the 66,220 seat building. More than just bringing the light in, ETFE also ensures the snow will stay out. The lightweight but strong material allowed designers to run a super span that includes a single 989-foot long single ridge truss the entire length of the field. The roof that sits over the 1.75 million square foot stadium is one of the lightest stadium roofs in the world, despite its snow load requirements. The roof is so minimal that the Vikings can still do flyovers before the games in an indoor venue.
Although no major problems occurred during construction, they appeared about 9 months after completion. The majority of problems occur on the northwest face of the building, which is 27,500 square feet. Problems occur when a winter or summer storm creates intense winds that loosen the zinc-coated panels from the building. Some of the winds are strong enough to blow the panels off the structure. After the panels have been loosened or removed by the wind, moisture gets into the walls and insulation. Enough water was getting into the stadium that puddles were being created in a women's restroom and a large storage area. Another issue that was only worsening the leaking issues is that the northwest face has a short time in the sunlight. Without the sun shining on the face of the building, insulation was not drying out, so whatever moisture got in stayed. In 2016, a new water barrier was added to hopefully stop the water seepage, which worked in a few places, but the northwest face was still experiencing leaks. A true fix came in 2017 when Tyvek was added underneath the panels along with more moisture barrier added between the panels. After the barriers were fixed, the panels were reinforced to the side of the building. As for the large icicles that were forming on the roof, a heat trace was added to the exterior edge of the roof to prevent the buildup of ice.